web server in a one-liner. Just remind me after the talk, we've got some time. I'll show that one because I think that's really, really handy. So I'll show that as well. The other one was the Swift. I found that was really interesting. I had the exact same conversation with someone, like, Swift, I really like Swift. It's just like Python. And they're like, is it like dynamically typed? I'm like, no, strongly typed. So how is it like, I can't actually tell you how it's like Python. But yeah, I agree with you. And I don't know why yet. So maybe if you know why, I'd like to know. So yeah, I'll hand over to us now, and we'll get underway. Is live stream gonna?
It's on.
It's on.
We have one viewer.
Alright, so I'm Arthur. I'm paid to, and I used to work as a software engineer for a company called Allied Telesis. They make routers and switches with Cisco competitors. And so I learned some. I wrote C there primarily, but I learned some Python there just because they had lots of most of their tooling was written in it. And they were splitting up a little Django thing for static code analysis. Well, they used GCC for static code analysis, and then put the results through it and put it up on the web through Django. So that was quite cool. That's where I got my first taste of it. And I used Scapy as well, heaps for testing the routers and making malformed packets and all that sort of stuff. So that's quite cool. So today I'm going to talk about kind of a creepy sort of idea, how to track people using a MAC address. I thought I'd explain first what a MAC address is. I'm going to assume that no one has really much networking knowledge. So what you do, this is how computers communicate with each other over the internet or over local networks or whatever. So you've got your PC, you've got your router, and you've got another router and you've got a server over here. So what happens is, if you're on a PC and you want to send any sort of information to your server, what happens is you address it, you use your IP address, which is the logical address of the server. Well, all of these devices have IP addresses. But if you want to address the server, you use the server's IP address, and then send it out. You send it out to your local router, which is the thing owned by Spark or 2 Degrees or whoever you use. You send a packet there, and the packet gets sent to the router with MAC address tags on it. It has a source, which is your PC, its destination, which is the router. And it also has the source IP address, which is the server, which is the IP address of your device, and destination IP address, which is the server. And through some magic of the internet, the router will know, based on the IP address, exactly what hops to take to go through it. So it finds its way, and it's really cool. IP addresses can change. Pretty much every time you reboot your PC, your IP address will change. There's a whole thing called DHCP, which is dynamic IP address matching. One thing that doesn't change, though, in this system is the MAC addresses. Every single one of these devices along the way has one set MAC address. And that's quite handy, because it means if you send to a particular MAC address, it's always going to go there. But it also means you get stuck with this. Your device is easily identified on a network. And this is quite handy. It's handy for networking. It's handy for spanning trees and all those other fancy things. But it's handy for some places in the US. I think it's like Walmart or Target, one of these things. And they use MAC addresses to track their users as they go, like through the supermarket or through the store. Because your phone has a Wi-Fi chip in it, it's broadcasting a MAC address out whenever it tries to connect to a wireless network, or even just passively, it just sends out what wireless networks are available to me. And it's quite a scary thing, and they have multiple routers placed around these huge warehouses or huge supermarkets, and they can track with some degree of accuracy where you are and how long you're spending at each aisle and all that sort of thing. And it's quite, I don't know, it's an interesting idea. It's a good idea for getting customer data and that sort of thing. If you wanted to find out what the busy aisles are and what aren't going so well. So I saw that and I thought, that's a pretty cool idea. Really creepy, but I think it'd be quite easy to implement, quite interesting to implement. And I thought, I know Python, it's far too difficult to write it up in C because it tends to take 10 times longer to write anything in C than it does for Python. And then above those in two languages I know, so move with Python. First problem I thought of was that the MAC addresses, I'll show you what they look like. Okay, so this is a MAC address here. It is 48 bits long. Always, for some reason, they always seem to be presented this way in pairs of hexadecimal numbers with commas or dots separating. They have no, I mean, they are always the same, but there's no way you can really tell what the device is just based on that number, except for the fact that the first half of it, these first 3 bytes, are the organization identifier code or something. It's basically the company that manufactured the Wi-Fi chip or the whatever thing in there. So yeah, the first problem was how do you match these cryptic looking signatures to actual devices and that sort of thing. So the IEEE maintain a big database, big list of how you match all these things up. So my first little project was the org matcher, we called it. It's pretty simple. If we'll just jump down how it's used. What it basically it oh, that's not it goes, here we go, download that file. It downloads the standards from IEEE, extracts them out using a CSV, which is not, it's further up. It's just a big table, and you can use just import CSV, and it actually just works. It's fantastic. It's all nicely escaped. You don't have to do anything fancy with it. It just comes out, and it's all just rows, and you can just iterate over the rows, and you can pull out where the MAC address starts and the different ranges, and you can add the organization name and the organization address. It's all quite straightforward because it's quite a nicely well presented table for you there. So, for example, how to use it. You just chuck this one in here. Copy. Is it control? Could be that command. It'll work. There we go. So we chuck this MAC address in. It's made by Apple. We've also got some extra information there that it is actually a MacBook Pro, so that's good. Confirm the scanner does work, and I can identify, give it a MAC address, I can figure out what company made it, which goes some way to figuring out who's who. So with that, I thought, okay, that's quite good. And then the next problem, keeping on this creepy sort of vibe, I thought, what can I do with this? And I thought, well, I live in a flat. My flatmates have no idea when they're home. I'm not sure what they're doing. And I thought, I can find out if they're home or not by checking out if they're on the network or not. So it's quite a simple little idea. Basically, it just goes and pings all of the IP addresses within the home network's range. So it's 192.168.178.1 all the way up to 255 or 254. It fills up the ARC table, and the ARC table is just a table of all the MAC addresses that it has seen, and scans through the ARC table and saves it all, presents it all to the user. So it's to implement the scanning part, it was quite with Python. It's amazing what you can do. So I think I just googled how to spawn multiple ping processes or something, and I borrowed it from this website. It's a ping suite little. You give it the network string. The Python has its own inbuilt IP address library, so you don't even need to figure out what IP addresses are in the range. It spawns a whole bunch of sub-processes. I think it maybe does 10 at a time or something. They all join a multi-processing call. Have you guys ever used the multi-processing stuff in Python?
It's really handy.
It is really handy. And for stuff like this, which is it's not writing any data, it's especially handy because you don't need to worry about concurrent reading, concurrent writing, sort of thing. So my Python script just sits there, waits for all these pings to send out, and it's about 10 seconds total, and once they're all completed, it just selects it. It does it all automatically. They don't just sit there polling it, and it comes back. And it returns all the pinnable IP addresses, all the IP addresses of devices that exist on the network. And then from there, we can, again, spawning. So if I use this part doesn't need to be quite so parallelized, so I just use process open, which is a sub-process library in Python, which is, again, really handy if you wanted to spawn these things. And that basically just, it takes your ARP program, which is looking up your ARP table, and you give it an IP address, and it will tell you the MAC address associated with that IP address. That's the basics of it. Also, the ARP table will give you the host name of the device. And the host name is quite handy because the host name will have the person's name and the name of their device, usually like James's MacBook Pro, Arthur's Android phone. It's all good. So from there, I was able to basically just see who was at home or not, and it was quite easily done, I think, with the Python. It's some of that multiprocessor stuff is a bit confusing, but it is really easy to go find information on Stack Overflow or whatever. That was quite good. I thought that's good. I've come to some, achievable level, minimum viable products. I think that's what you've got to go for. I thought, what's the next stage? Actually, we want to track the people. We don't just want to know if they're on the network or not. We want to track them. So to do that, I used a database, SQLite, how do you say it? I'm sure you say it, which is quite handy. I don't know if you guys use database stuff. It's really good. I made a terrible decision to not use SQL Alchemy. I would really highly recommend, if you're doing anything with databases, to use a library called SQL Alchemy or SQL Alchemy. You know what it's called?
Yeah,
SQL Alchemy. And it's really nice. You make models, which are just classes in Python, and it'll create all the database schema for you. It's really handy. I went the handwritten way, writing out all the SQL commands by hand, which is not so fun. It's all right. I mean, I got it working, but it's just not quite as easy as using SQL Alchemy. Fantastic piece of software. So got the we'll jump back up to the top. This is the data. The data stuff in a different file. That's right. So we've got the device tracker file, which is, it has all these databases, bits and pieces, which is the stuff hopefully you will avoid by using SQL and not bothering to write all this horrible antiquated looking language, which is SQL. But I mean, it's very powerful if you know what you're doing, which I don't generally. It's quite a simple database. It has a device table, it has a timeline table, and a timestamp table. And the device table is just stores all your devices that it's seen so far. The timeline, and the timestamp is every time it's run a scan, it'll just save the timestamp, and the timeline is basically sort of like a multi table that matches up when each device has been seen, whether it's being seen in that scan or not. That's that's good. And we've got some simple little getter functions, which if you use SQL Alchemy, will write all those getter and setter sort of functions for you. Nothing too much interesting else in that file. So,
does SQL Alchemy work with SQLite? So
it does, yeah. So, and that's the other advantage of SQL Alchemy, is that it will work with multiple databases. I've only ever used it for Postgres and SQLite, but works for MySQL, maybe Oracle DB, I'm not sure. But yeah, it's a really good one, that one.
Even the in-memory one, right, which is
SQLite has a memory option, yeah. Cool. So I've written all this code, and I'm not sure about you guys, but I have all these. At the end of it, I just have like a list of maybe 20 functions, and I'm not really sure how to exactly tie them in together. There's another really good library, argparse, which is really handy. I'm not sure if you guys ever write command line tools, It's a really, really good tool to use. It'll give you multiple different options about how to select different types of flags and different arguments coming in. The other option, which I did for this augmenture one, this is the ugly way to do it, is to where is it? It's not one. Oh man. Oh, I see what I've done. The dumb option, but it still kind of works, is to use, if you're a C programmer, you probably recognize it. You've got your argv, and you've got your argc, which is the argv. And you can, argv is basically just a list of all of the commands that you've put in. So for example, the argv for me running this bit of, this here will be argv naught will be vim, argv1 will be the augmentation. So in this example, it's because there's so few options, I just went the simple dumb way. Did that. If the first character in your first argument contains any of these letters, which relate to the different arguments of your function, then just do it. It's quite a dumb way to do it, but it's fine if you've just got a stupid little one-line command to run. If you want to do anything more, then probably argpass would be the way to go, which is an example of how to use it is here. So you just create a parser. You can add. It's pretty common to use. There are two different. You have a single character flag and then like a double dash with the full word for the name of your command or the name of your option. So I've done that with all of these. And you can, if it's just is the flag present or not, you've got the store true. But if you've got like, for example, this add name command line option has two options, it's got two arguments, the MAC address and the new name. There's all these. It'll create that argument for you, and then so you put all these different options and you add all these arguments to your parser. You pass your args and you get this really, really handy little your args variable out, and you can just go if the trash database flag was used, then it's true. If it wasn't used, then it's false. We've got add name. The args add name will come back because it had two arguments. It will come back as a list of both of the arguments, which is quite handy. It's really the tutorial on the Python website for argpass is really good. It's really worth checking out if you guys make command line programs. That's not pretty useless, but yeah. So I thought I'd show you what's capable of my little device. What have we got here? So we can. Another advantage of argpass is that it creates your dish help. So it will list out all of your different options that you've, all different arguments that you've made, and all the different help strings, and give it these nicely formatted bits and pieces. It all looks very Unix, and it all looks in keeping with how your other command line programs look. So the first part, maybe we'll look at the listing all the MAC addresses that it's seen before. So this is, I've set this up to turn on every 5 minutes and have a scan of the network and stop.
This is your computer at home.
This is my computer at home. Sorry, this is my computer at home. I've logged into it. I probably should have made that clear. So you can see the Fritzbox is our router, and I've got a Cisco switch. I've got my desktop's on. Got my laptop is on. And so we can see the all the different devices that have been connected. We've got the host name, which is quite handy for matching the MAC addresses. So we've got the MAC addresses as well. We've got the organizations. We've got the that's what we've got. And you can start adding names to these different to the different options. For example, we know this is James's we know that's James's PC, his MacBook, so we can use our fancy arguments to go. Oh, actually, I can't remember what the ad is. We've got the ad is dash N, no, N, dash A. For the for this option here, this ad name. So we can go MAC address first. Which is quite handy, and then it'll come back and it's given a name, and it'll save that name into the database, which is handy for the next step. So now I've kept this running for the last couple of days, and I've got it for another library I haven't used in quite a while is Matplotlib, which is really fantastic, but also really difficult to use, I find sometimes. But so I drew up a quick little graph drawing thingamabob. So it just gets all pretty much everything in the database that it can get, creates a whole bunch of subplots, removes all the ticks, draws it nicely. It's quite good. It's a really good library once you know what you're doing with it. But I don't know, I find it's quite a steep learning curve. I'm not sure. Maybe you guys have different experiences with it, but if you want to do anything other than just basic line drawing, it can get difficult quickly. I found. I'm not sure. But yeah, so that draws a nice graph, and I've get out of it. I had it open in one.
Oh yes.
There we go. And so we can draw the scratch. So we can see that blue means on, white means off, or just away. And we've got the timeline down the bottom. So we can see that the router's always on, switch is always on, my desktop's always on, my laptop is not used very often. You can see quite clearly that this is me at home, this is me at work. This is me at work. I've removed the names of the other people, but you can also quite clearly track, where they are and what they're doing. It's not perfect. I'm not exactly sure what the issue with these bits are going on here, but so if you look at the times, there's a big gap missing here. That's about 6 in the morning or something. They're probably home, so should be something wrong with the script there. I'm not sure. The other issue is, and this is quite an interesting one here, is this MAC address. So Apple are quite well aware of the fact that these MAC addresses are used to track people, and they occasionally put out spoof MAC addresses, especially when you're not connected to a Wi-Fi network, explicitly so they can get around these people trying to track you through their supermarkets. So this is a spoof MAC address that I managed to find, because that was, I'm not sure who it is, but that's like a device that doesn't exist, that's ever connected to our network. And the host name associated with it was an Apple device. So that's quite an interesting technique that Apple's done there, is they just, until you've connected a network to the network, they'll put out a fake MAC address so that you can't do exactly this. I think so probably similar problems with these gaps. A lot of my flatmates have Mac products. I think probably they're smart enough to realize that being constantly pinged every 5 minutes to drop some packets or something like that. Or it could be Wi-Fi issues. So I need to apply some low-pass filtering through the data and fill in some of these gaps. So someone probably wasn't away during that gap. They probably just need to assume they were there and assume my program or something failed along the way. So this is really creepy, and I don't think I'm going to keep it going. But I've got the data over the last 3 days just so I had something to talk about and show you that it does work. And then, I mean, if I can do it, then I'm sure that other people are doing it as well. I'm sure like probably like university networks and corporate networks and all that sort of stuff. I'm sure they would be doing similar, more comprehensive sort of scanning, and all through the power of Python.
We're going to sell it for timesheets for staff.
I mean, maybe.
Does it know what project you're working on? So the code, I've chucked it up on GitHub, which is the way to do things these days.
To enable creepiness. Open source creepiness.
It really, you do feel kind of gross doing it. So actually, I think I will turn it off. That's sort of a fun little exercise in programming, which I don't do very often. I don't do it in my day job. day job very much at all, so it's quite good to get back into it. The Reboot is actually quite old, I might update that. Yeah, I think that's about all I wanted to cover Python-wise. I'm not sure. Awesome. Do you guys have any questions? Then,
Well, big round of applause and then we'll
Oh, sorry.
Can you get signal strength data?
yeah, so the server that's running the script is actually plugged in Ethernet, but I have plugged a little Wi-Fi stick into it, and you can get some signal strength data off it. It's not. You have to use this program called, well, you have to. The program I found is like aircraft NG or airborne NG or something like that. I'm still figuring out how to use it, but you can get signal strength from that.
For each mechanism.
Yeah, pretty sure you can. Yeah. So then you could potentially start tracking how far away they are from the router or from the PC.
How much they move around all the time.
Yeah, exactly. Yeah.
I'm not sure if you know, but basically any devices you can change the MAC address.
You can do, yeah, but
Yeah. So if you want to
Standard
try to
users.
counter to this, which constantly generates random MAC addresses and use that for branches.
yeah, it would. I know you have to have root on your Android device to change the MAC address, but yeah. And yeah, Apple does it automatically to some degree.
And Bluetooth devices with MAC addresses.
Yeah, they do. Yeah.
So is there there's a finite number of these MAC addresses?
There
Are we
is.
going to run out? And is there
They seem to be better managed than IPv4 addresses, so I'm not sure actually. Presumably they'll exhaust it.
You do have to go through a registration process.
Yeah.
And you get assigned blocks. It is a commercial.
There's also a lot more of them than IPv4 addresses. 48 bits rather than 32.
Yeah.
Okay.
Which is quite a lot more, probably billions. Probably not enough. But yeah, it's all managed through the IEEE. You can get all the data off them.
So that was a free download for the CSV, that data that you fed into your database.
Yeah.
You just go to their website and it's there.
It's all just there, yeah.
So notice they had their address, one infinite loop for Mac address, for Mac products.
Yeah.
That came from that database.
It did. I didn't do any fancy lookup stuff. It was all just with it. Yeah.
And that's what you pick up when you register for a block. That then becomes public information. Associated with those. The last bit of commercial Python that I wrote was actually managing a block. MAC addresses for a manufacturing company.
Oh, right.
Just based around that. So that they which ones they were allowed to burn onto their devices.
Very cool.
I was thinking if you plotted on a world map the addresses that you found of the manufacturers, you could say, like, in this room, how much cargo had been shipped and from where, assuming it actually came from America rather than China or wherever. So right, so you just have a graph of all of the stuff that had got into this room.
That's for MAC address. How do you know anything more about that? How does that? I don't know. I don't understand exactly how that works because you've got your IP address, obviously, and it starts at the IP address. But then, how does that IP address map to a MAC address, or are you snapping something?
I think it's during the connection process. It will change MAC addresses. I think that's how it works, and that's how I just managed to catch it the 2 times or so that it did. I think. I'm not 100% sure how Apple have implemented it, but it's something like that.
And so your laptop or box was actively pinging these machines to fill up your ARP table. Is there another way to just monitor what traffic, what these MAC addresses going around? Do you have to have this active pinging?
If you were sitting in the router, then you could definitely do that. You could also, set up a device between your router and the rest of the network and see everything that comes through. Would be another option. This is just the easiest way. There are other tools like Egnet, which I've used. That's mostly for layer 3 and layer 4 scanning. I'm not sure if that gives you MAC addresses. I'm not sure.
If you are on Linux, you can use the ARP command to get the ARP tail of your Linux box small.
Yeah.
Because that's what you call like a sub-process.
Yeah, I was using sub. Yeah.
So most of the heavy lifting with the network stuff was done with command line.
Yeah, so
on
pinging
Linux, yeah.
On Linux, yeah. But I think ping and ARP are both present on Windows and be the same, but the commands are definitely there. So it wouldn't be too hard to move it over. Yeah.
Awesome. All right, thanks again.
Thanks very much.
So what we do, we haven't got another official speaker, so I said we could do like a free-for-all session where if you've got something interesting, I'll start off with the Python web browser in a single command line. That's pretty awesome, and then just sort of throw suggestions at me, and I'll see how far we get with putting them up on the screen, and then if we run out of steam, then we'll just head off home or something like that. So. That's your home machine there. Okay, so what direction? Okay, so that was Python. Now this depends what version you're using, because it's changed between 2 and 3. So how many people use Python 3? Yes. Oh, we saw it waving. Yeah. Okay, so I'll show you Python 3 first. Which does anyone use the which command? Pretty handy. So if I want to know this, I might have multiple versions of Python installed on this machine. Like, where is this executable Python? I can actually see that. I think I actually might have a Python 3. Cool. So it doesn't actually tell me what this is pretty useless actually. I could go Python version, would be even better. Okay, so in Python 2.7, the -m argument allows you to instantiate a module, any module, like in the standard library. So I could actually create, like, call Python and then get it to load the regular expression library. And in some of these standard libraries, they do something special when you do this. So I don't think RE will do anything special. Just sort of probably gets to the end, loads all of the things into memory, and then just exits. So it's pretty useless. But there's a really good one, which is simple HTTP server.
Remember the capitalization.
Yeah. So what that's going to do is there's a module in the standard library called simple HTTP server, which lets you create simple HTTP servers. But if you do it from a command line, it will automatically create one from your current directory. So if we do that, serving HTTP port 000, which is listening on all my interfaces, port 8000. So if I actually went to localhost port 8000, there's a directory listing of my home directory, which is really, really, really convenient. And you can see what's happening here. So I use this all the time because when you're on an embedded Linux machine, for example, this Python usually is also available. And because it's a standard Python library, you have a way of getting files in a reasonably fast capacity off your device. So if you needed to get 100 megabytes of, I don't know, or maybe a whole bunch of images or whatever you've got on your embedded Linux machine, you want to download them, you can just create the web server, go to it with your browser, and then just download them, which is pretty handy. But in Python 3, they changed things. So now it's http.server, which is way nicer. But I still have to remember both. And it does the same thing. You can, I think there's some arguments for the port. So I can change the port to 8080. Oh, no, I can't. There's no P. Yep, or that bind, which was different. If I didn't want to listen on all my interfaces and I only wanted to listen on one or two of them, what that means is I've got a whole bunch of different interfaces. I might have Wi-Fi connected, I might have Ethernet connected. So by default, it's listening on everything, but I might only want to listen on a particular one. So that's that, which is super handy command. Has anyone got another suggestion they use?
There's a Python tool called Grip that you've got Markdown for your Git repository.
Ooh.
You can just from the command line and it renders it in your browser. You want your Markdown rendered in your browser before you do a commit.
That is awesome. Okay, it is all grip. Right. I actually think this might fail. One thing I do, so does anyone use virtual environments? Yes? Does anyone not know what a virtual environment is for Python? Is that no you don't know, or no yes you do know? Oh, you know, okay, cool. So I have this little handy thing that I don't want to, because I want to force myself to use virtual environments. So if I ever call pip without having a virtual environment, it's going to say, sorry, you can't do that. I forget exactly how I did that. I think it might be a something in my bash RC. Yeah, so there was pip require virtual env. Yeah, so I think if you do that, then you're all good to go. But then I had a gpip, which was like a global pip. If I actually really wanted to do it, I could do that. So I can do a gpip install grip, which is not a standard command. Obviously, it's just what I've done myself. But I found it really handy because I catch myself all the time, even though it does tell you what virtual environment you're in the shell.
You're doing a lot of requirements there, aren't you?
Yeah, just go straight into my computer. That's fine. Let's see if there's something useful in here.
You clone mine if you want.
I've got to read it here. So grip readme. Okay, maybe there's something strange going on with my.
You don't have to sudo pip install, do you? Sudo gpip?
Should be. It goes into a non-root location. Strange. No grip?
Yeah, which I think will only find it if it's on your path.
You know what? It's probably gone to my Python 3.
Yeah.
Yeah, it's a good point. Let's have a look. Oh, no, there we go. Let's use the Python 2.7. So I think it's actually a pip3 as well. If you need to install something Python 3 with pip3. I haven't set up a gpip3. That's going to run. Okay, well, I'll let you guys experiment with this yourself, but don't actually can't get that quite running. Does it use the GitHub flavored Markdown as well? So it looks like a GitHub page.
Indeed, okay. Yeah.
Oh, this is actually really. I'll leave that for later. Bad things will happen. So I accidentally created. This is plaguing me still. Let's go into a temporary directory. So in Linux, you can have anything in your directory names, your file names. They can contain anything except for forward slashes and dots. Oh no, you can have dots, just forward slashes. I think it's like literally just forward slashes the only thing because that separates things like the command line, which is bad when you do something like let's go into an NZ code inside here as well. So I've got nothing in this directory. If I do create a file called till. Now I have, oh.
We just touched a home directory.
Oh, God.
Oh,
okay, hang on.
RM minus RA.
I'm still good. Okay.
Are you still recording still?
Yeah, we're still recording. We're watching an
All right.
online.
With you can play with text like that.
Thanks for reminding me. I should actually remember that. I've got a whole bunch of stuff that's now on my filming, but just briefly flash up. Someone's going to freeze frame and like. Okay, so if you create that, right? So now I have a file called till. Now, if you create this by accident and you're like, oh, actually, what I made a directory, and like, well, how do you remove this directory, right? The rm is removed and -r for recursive because it's a folder. Well, this is a file to be safe, but it was a folder that created. rm-till, and then like just went for it. But of course, till expands to your home directory location. So if I normally go echo till, it's my home directory with everything in it. So I started deleting my whole home directory, and it just went for it. And yeah, I stopped about 2 seconds in when I realized what I'd done. But it's not something you can undo. Those files are gone. I considered just like stopping, like hands off, shut down, rip the disk out. But I just sort of thought, okay, I'll just do it. I'll see how far I get before, like how many months down the track am I going to still be finding this thing? So what I did is I did an ls of my directory, and then just looked at the recently accessed dates, and found out that it had gone. It creates multiple like threads to do this. Like, oh, this is a big job. We're going to start like 4 or 5 threads at the same time and just like delete. So I could see 4 or 5 different directories that it had found and started recursively deleting. One of them was my gconf directory, which is like your GNOME config settings. So some programs just stopped working, so that was really bad. I actually just once you actually open them up again, it'll resave your settings and you'll be okay. The worst one was my Qt install. That was in my home directory, and I don't know what had gone from there, but things just didn't go anymore, so I had to re-download Qt. Luckily, I create little snippets for my config files. So if you, like, I know GitHub has like a gist. So if you have like a little file you want to keep a little snippet of, I sort of upload it to my gist account. And you can create private ones. And so all my little RC files for like my bash RC and for another one I removed was my mercurial config file. So, but I had them created because I was showing somebody else how to set their machine up, and I said, right, here's all the files that you need. So I could just go back and paste them. But I'm still finding things where it's just. So to be clear, the best way to remove this file would be with. Now see, I'm not actually clear because if you do this, it depends where the shell is going to expand this till. And so does it expand it first and then pass that to RM? And is RM going to expand it again? I don't know. So the best way I found to delete this is to find it in the user. I love GUIs now. It's just amazing. You go. I can't even open this directory, and then just delete. So I'm just hoping that
it doesn't use the shell underneath.
Yeah, that they've escaped whatever they need to do. All right. So what was it? Well, I think I got a bit sidetracked.
Well, while you're putting things in your gist, there's other people that are saving their stuff that is open source, and the one I use all the time is .gitignore for Python.
Gitignore. So is this gitignore.io?
Just Google gitignore Python, and it will get you there.
I don't know if this is the same one that you're mentioning, so I'll just do both. So the actual GitHub repository gitignore. So it's got them all in here. Is this for the gitignore.io service? Okay, so if anyone doesn't know what gitignore is if you're using Git and you're going to commit your files, you can say there might be some files you don't want to add to your repository ever. So maybe it's a compiled binary, or maybe it's a key for your Amazon deployment keys, or something that you never want in your repository. Then you could add it to your gitignore file. Best thing is not to have it in that directory in the first place, but then Git will basically ignore it and it doesn't know about it, and it'll never show up in your Git status or anything like that. So it looks like here you've got a whole bunch, and is there a Python gitignore, and they've gone through and found all of the different things that you might not want in your repository, like it's probably got the compiled PYC files if you've ever seen those, any eggs from if you're creating packages. So there's gitignore.io, which if you're creating a new project, you can start typing in different technologies you're using, like Python. I think you might have to actually click on it. Yeah, and then maybe we're using OS X.
Oh, and you'll add them all together.
Yeah, because you might need some special ones for your particular mix. There might be a Swift one. Maybe there's Django. Oh, there's a Django one. And then they'll generate you like a combined PYC, like a combined gitignore file that you can just input. That's gitignore.io.
If you start a project on GitHub as well, it'll ask you what kind of gitignore you want and put all the nice readmes in and licenses, which is quite handy.
I noticed you had a license in your one. I was quite impressed actually.
I think working in IP, you should probably put a license on it.
There's a really good talk. Was at one of the Python conferences by Brenda Wallace on copyright for software in particular. And yeah, there's some really interesting things around there. So if you go for Brenda Wallace copyright Python, I think she was at, yeah. So it couldn't even be on the NZPug YouTube channel. Yeah, there it is. So that was one of the a couple of years ago, no, last year. Really good book on copyright. Yes, and actually the interesting thing I found was the implication if you don't put a license on it, what happens then? And then if there's no license, then it's basically you just fall back to copyright. So you've made this thing, it's your thing that you've created. You've written this work. No one can literally copy it and then claim it as their own. Like that's what your copyright law is protecting. You know more than me, but that's really, really long in New Zealand for. I think software falls under.
Solitary work.
Yeah, like I'm writing a book.
Life plus 50 years.
Yeah. So your bit of code that you put online, after you die, 50 more years, that's when people are actually allowed to use it. So her talk was all around that's a bit absurd for software. Might be great if you write a amazing novel and you think your children should be able to benefit from your novel, or your estate's going to be so massive, I don't know. But for the code that I've got to get, So, has anyone come across TLDR legal? One, yeah. TLDR legal. Too lazy, didn't read is what TLDR stands for. But TLDR legal is all these licenses that people talk about. It's really, really hard to read. And if you're trying to choose one for a project, like which one is best, what one suits me. So you go to this website, TLDR Legal, and they've kind of summarized all these different licenses. And the full text is available too, so you can go through it. But for example, let's look at the GNU GPL v3. And so it tells you, like, oh, okay, you can use it for commercial use, but I cannot hold liable, and it might tell a bit more. And what do I have to do? I must include the original, state changes. Just think about that. So if you come across a project that has a funny license, you could go onto this website, throw it in there. There's all sorts of licenses. There's Apache license, and they all have sort of subtle sort of differences. And it's especially useful if you're trying to use this in a commercial project and you're wondering, what am I allowed to do? And then of course you've got to read the actual full text because you're just trusting some guy on TLDR legal. Like, where do you get your legal advice from? I was literally too lazy to read my legal advice. Anyone else have any suggestions?
Anyone keen to do a talk next month?
Vaguely Python. What I find interesting is that everyone's story at the beginning with how you discovered Python, like that's probably really interesting for everyone else. Like for you it might be, I just use Python every day. It seems so natural, but even the strange topics can be really, really interesting. So
we're happy for short talks as well. You notice Jeremy just went for about 3 short talks right there. And that was just straight off the top of his head. You don't have to have slides. You don't have to have pre-prepared Git repositories. You can just talk about whatever drove you crazy on Tuesday that you finally figured out, if you like. So yeah, if you want to talk to us afterwards or volunteer something, yeah, just contact us on Meetup or talk to us afterwards.
Cool. All right. Thanks for coming, guys. The hands-on meeting is